All right, this is chapter 1, lesson 1. This lesson is all about rates. And this lesson goes in a strange order a little bit. So um, I will try to remind you when to take notes in your note packet, okay? We are going to begin with a physical challenge. So here are the things that you're going to have to do. Set a timer for 2 minutes. Whatever electronic device you're using right now probably has a timer feature on it, okay? So if it's an iPad or a cell phone, use that timer. Next, I'm going to ask you to stand up and do as many jumping jacks as you can before the timer goes off. If you are in school right now, please ask your teacher if you can go out in the hall to do this, okay? Count as you go. Keep track of how many jumping jacks you've done. Just record that number on a sheet of paper, okay? So you are going to pause this video. You're going to set a timer for 2 minutes and go do those jumping jacks. Okay. So hopefully you are finished with your jumping jacks. What we want to do now is we want to use the data that you collected, that's the number of jumping jacks you did, to write the relationship between the number of jumping jacks you did and the number of minutes you had to do them. So I do not know how many jumping jacks you were able to do, but I was able to do 41. Okay, 41 jumping jacks. I'm just going to use JJ for jumping jacks in those 2 minutes. Okay, so what we did here was we wrote a comparison, a ratio of the jumping jacks over the time. And what we did was we included our units this time. We included jumping jacks and we included minutes. This right here is what we call a rate. A rate is a special type of ratio. So it is a ratio, but it's special because we include the units. And we include the units because they're different. We're comparing 2 very different things here, jumping jacks to minutes. Okay, so for the rest of this video, this is the rate that I'm going to use when we solve problems. Okay, your number may be different and that's okay. You can go ahead and write yours down. Next thing I want to talk about are some qualities of rates. Okay, so these are some things that we know about rates. You do not have to write these down. Rates compare 2 quantities, just like ratios. But the difference between a ratio and a rate is that rates have quantities that have different units. So feet, inches, pounds. For us, we did jumping jacks and minutes. So because the units are different, we have to include them in the actual rate when we write it. All right, so that's what's setting us apart now from a ratio. We're still comparing 2 quantities, but now we're putting units in our work. I'm going to jump back here really quickly. We don't read this as 41 jumping jacks to 2 minutes. Okay, that's not rate talk, that's ratio talk. Now that we're in rate mode, this bar is read as the word per. Okay, not per like a cat, per as in for each or for every. So this would be read as, I did 41 jumping jacks per 2 minutes. Okay, so we read that as per instead of to. Rates are very common in real life. We see them all the time. We can think of 1,000 of them. This is a lot of real life math right here. Okay, so I know what you're waiting for. You're waiting for the definition of a rate. Here's your definition. You can put this in your notes. The definition of a rate is a comparison of 2 quantities in different units. So similar to a ratio, but different because we have those units there. Okay, let's move on. Back to our jumping jacks rate. I'm going to remind you that mine was 41 jumping jacks per 2 minutes, right? Yours is probably very different than mine, probably very much higher. So the question asks, how many jumping jacks did you do in 1 minute? Okay, so if I did 41 jumping jacks in 2 minutes, and I want to know how many jumping jacks I did in 1 minute, or could have done in 1 minute, all right? This is going to be a division problem for us, right? We want to turn that 2 into a 1, and to do that, we're going to divide by 2. And since this is a rate, we're going to keep it equivalent, so we're going to divide our numerator by 2 as well. Don't worry that 41 is not evenly divisible by 2. It's okay. I will get 20 and 5/10. We'll do decimals here. So that tells me that I can do 20 and a half or 20 and 5/10 jumping jacks in 1 minute. All right, that would be a very special rate. I'm going to write it a little nicer down here. 20 and 5/10 jumping jacks per 1 minute. So now that we've taken our rate and we have solved it for 1 in the bottom, it has a special name. Okay, so it's a very special type of rate. We call this a unit rate. Unit means 1, and my rate has a 1 in the denominator. Okay, so this is a unit rate. They're very, very helpful. Take a look at some notes about unit rates on the next slide. Okay, you do not have to write these down. We'll just go over them together. Unit rates compare two quantities in different units, so they are just like rates in that respect. What makes them different from rates is that they're solved for 1 unit in the denominator. So all of our unit rates will have a 1 in the denominator. And these are your most common types of unit rates, and they're used a lot in stores, street signs, and medicine. So a couple quick examples. Stores, you go to the grocery store and you ask to buy a pound of lunch meat. They tell you lunch meat costs $4.50 per 1 pound. Street signs, when you're driving down the street, down the road, you see the speed limit. It tells you that the speed limit is 60 miles per hour. That means 60 miles per 1 hour. That's a unit rate. Medicine, a lot of dosages for doctors, if they take your blood pressure. They want to know your heart rate in beats per minute. So these are very, very common in real life as well. Okay, very useful. So you're waiting for a definition. I know this is what you can put in your notes. The definition of a unit rate is a rate solved for 1 unit in the denominator. Okay, so why do we want to use unit rates? Why do we care? Okay, this is a practice problem. It is not in your notes, so you can just pay attention, but I will give you a hint that it's very much like number 4 in your notes. Okay, so Jason can type 75 words in 3 minutes. We can write that as a rate. Words in the numerator, minutes in the denominator. We always want to put our time in the bottom. Okay, time in the bottom. So it asks us, how many words can he type in 5 minutes? Well, first thing we want to know is how many words can he type in 1 minute? So first we're going to change this to a unit rate. And to do that, we're going to change our 3 into a 1. So we divide by 3. Divide by 3 in the numerator as well. And that's going to solve for how many words he can type in 1 minute. All right? So we do a little division here. 75 divided by 3 is 25. Jason can type 25 words in 1 minute. And that is our unit rate. And now that we know our unit rate, we can solve the rest of this problem. We want to know how many words can he type in 5 minutes. So that means we want to figure out what will our numerator be when the denominator is 5 minutes. Okay, so how did we turn that 1 into a 5? Well, we multiplied by 5. We want to keep our ratios equivalent, so we multiplied the numerator by 5 as well. 25 times 5 is 125. So Jason can type 125 words in 5 minutes. Okay, so we were able to solve this problem by finding the unit rate first. Once we knew the unit rate, we could do a little multiplication to solve for the number of minutes in the question. Like I said, this is very much like number 4. So when you do number 4, look back at this problem if you need a little bit of help. Okay, so a lot of vocab so far in today's lesson. And this is a type of Venn diagram. Usually you're used to Venn diagrams having 2 circles with some overlap. This is a Venn diagram that's called a nested diagram. Okay, so in our big outer circle, we have our ratios. Ratios are anytime we're comparing 2 quantities. Okay, now if we get a little more specific on our ratios, we can turn them into rates. Turn them into rates by adding units to our quantities. Okay, so if we just had 2 to 3 here, that would be a ratio. If we have $2 per 3 hours, that would be now a rate because we have units in our comparison there. Okay. Finally, if we want to turn our rate into a unit rate, this is when we solve for 1 in the denominator. So we would divide the numerator and denominator by 3, and we would get 67 cents per 1 hour. And now we have turned that into a unit rate. Okay, so just a comparison of those 3 words. Just to clarify, unit rates, all unit rates are rates, all rates are ratios, but it works differently in the other order where we have to kind of add certain qualities to turn a ratio into a rate and a rate into a unit rate. All right, so here are your notes. Make sure these are written in the notes section of 1.1. When writing rates, this is our guide. We talked about this a little bit on an earlier slide. Time always goes in the bottom. Money always goes in the top. So if you're given a problem that includes money, make sure that number goes in the numerator. If you're given a problem that has time in it, make sure that always goes in the denominator when writing your rates. Other note here, to turn a rate into a unit rate, we are going to divide by whatever number is in the denominator, because remember, we want to get a 1 in the denominator for a unit rate. All right, your to-do list for this lesson, I want you to do your practice problems for lesson 1. Make flashcards for your new vocab words. Those words are rate and unit rate. And when you are ready, you can start lesson 2.